Okay, so this is example 4.6 from your textbook now. Let's take a look at it. Alright, we're again supposed to find the forces in each one of these members. Alright, so we have 2,000 pounds acting down, 1,800 pounds acting across, and so I need to draw a free body diagram. Okay, so our free body diagram is going to look something like this. This is point B. Okay, I have a force in this member, and I'm going to say it's acting up. I have a force in this member. I'm going to say it's acting up. Alright, then I have 2,000 pounds acting down and 1,800 pounds acting across here. Alright, so let's call this one F1. We'll call this one F2. Okay, let's think about the angles of these forces. Okay, this force is going to be at an angle of 45 degrees. That angle is going to be 45 degrees. Okay, and this angle is going to be 30 degrees. Right, same logic as before, in that there's an imaginary right triangle here. So this angle is 90, that's 60, 90 minus 30, minus 60 is 30, and 45 minus 90 minus 45 gives us 45 there. Okay. So this one is 45, but this one is actually 60. Sorry. Okay, because that angle's 30, that angle's 60. Alright? Okay, so got the same tricks as before. We're going to start with sum of the forces x. They're equal to 0. Okay, and we have 1,800 pounds acting in a positive direction. Then we have minus F2x because it's going in a negative x direction. Okay, and then we have plus F1x. Okay. Okay, so let's look at what this looks like. We've got, come on, here we go, 0 equals 1,800 minus F2 cosine 60 plus F1 cosine 45. Alright, so we have one equation, two unknowns. We need to rearrange to solve for one of them, so let's move F2 to the other side. So get F2 equals 1,800 divided by cosine 60 plus F1 cosine 45 divided by cosine 60. Alright, so F2 becomes $3,600 plus F1 1.414. Alright, now let's write the sum of forces Y. That's equal to 0. Okay, and we have F2Y the way I've drawn it and F1Y acting in a positive direction. And then we have minus the 2,000 pound external force. Okay, so that means we have 0 equals F1. Okay, the angle there is 45 degrees, sine 45, alright, plus F2, sine 60, minus 2,000 pounds. Okay, so now we're going to substitute in F2 from the sum of the forces in the x direction into this equation, and we get okay, so now we've got to do a little calculating. I'm going to go ahead and move the 2,000 to this side. Alright, F1 sine of 45 degrees. Okay. Alright, then I've got to distribute that sine 60. And I get 3,117.7 plus 1.22 F1. Okay, so now I just need to do a little combining of terms. 2,000 equals let's see, 1.932 F1, oops, F1 plus 3117.7, alright. I go ahead and move that 3,000 to the other side. I've got 2,000 minus that. So I get negative is equal to 1.932 F1. Alright, divide that out. And I get F1 is equal to a negative 578.5 pounds. Okay, so what does that negative sign mean? It means that I drew F1 in the wrong direction. Okay, that it should be going down here. Okay, so, but it's worked out negative because my drawing and my equations depended on it being drawn in that direction, so I just keep the negative number now and finish out my calculations. So let's substitute back in for F2. Alright, and I get F2 is equal to 2,782 pounds. Okay, so this ends our examples on concurrent forces.